In this lesson, you will learn how to configure and use SSL VPNs. SSL VPNs are an easy way to give remote users access to your private network. In this lesson, you will explore the following topics. Describe SSL VPN, SSL VPN deployment modes, configuring SSL VPN, realms and personal bookmarks, hardening SSL VPN access, monitoring and troubleshooting. After completing this section, you should be able to define a virtual private network, VPN, describe the differences between SSL VPN and IPsec VPN. By demonstrating competence in understanding VPN concepts, you will be able to more effectively understand how FortiGate manages SSL VPN methods. A virtual private network, VPN, creates a tunnel that gives users or remote LANs secure access to your private network as if they were connected to your LAN. A VPN is often used when LANs are separated by an untrusted public network, such as the Internet. As well as providing users with secure access to private networks while they're traveling, a VPN can also interconnect branch office networks located across the Internet and even on the other side of the world. User data inside a VPN tunnel is encrypted for privacy. It cannot be read, even if it is intercepted by unauthorized users. VPNs also use security methods to ensure that only authorized users can establish a VPN and access the private network's resources. They typically also provide tamper-proofing. Most VPNs are SSL or IPsec VPNs. FortiOS supports both, as well as less common, weaker VPNs such as PPTP. In this lesson, we will focus on SSL VPNs. How are SSL VPNs different from IPsec VPNs? The protocols are different. SSL and TLS are commonly used to encapsulate and secure e-commerce and online banking on the Internet. HTTP. SSL VPNs use a similar technique, but often with non-HTTP protocols encapsulated. SSL resides higher up on the network stack than IP, and therefore it usually requires more bits, more bandwidth for SSL VPN headers. In comparison, IPsec uses some special protocols. The primary protocol is ESP, which encapsulates and encrypts UDP, RDP, HTTP, or other protocols that are inside the IPsec tunnel. Also, IPsec VPN is a standard. It can interoperate with multiple vendors and supports peers that are devices and gateways, not just user clients with FortiGate only, like SSL VPN does. The client software is also different. In an SSL VPN, your web browser might be the only client software you need. You can go to FortiGate's SSL VPN portal, an HTTPS webpage, and then log in. Alternatively, you can install a plugin or FortiClient. This increases the number of protocols that can be sent through the VPN tunnel. In comparison, to use IPsec VPN, you're usually required to install special client software or have a local gateway, such as a desktop model FortiGate, in order to connect to the remote gateway. You might also need to configure firewalls between VPN peers to allow IPsec protocols. However, IPsec is a standard protocol supported by most vendors, so a VPN session can be established not only between two FortiGate devices, but also between different vendors' devices and between a gateway and clients. It's highly extensible and configurable. By comparison, SSL VPN can only be established between a computer and a vendor-specific gateway, such as FortiGate. After you've logged in, the SSL VPN connects your computer to your private network. No user-configured settings are required, and firewalls are typically configured to allow outgoing HTTP, so technical support calls are less likely. Simplicity makes SSL VPN ideal for non-technical users, or users who connect from public computers, such as those found in public libraries and internet cafes. In general, IPsec VPN is preferred when tunnels must be up continuously and interoperate with many types of devices, while SSL VPN is preferred when people travel and need to connect to the office. Good job! You now understand basic concepts about the function of SSL VPNs and how SSL VPN is different from IPsec. Next, you will learn about the SSL VPN deployment modes supported by FortiGate. After completing this section, you should be able to describe the differences between SSL VPN modes. By demonstrating competence in understanding the different ways FortiGate allows SSL VPN connections, you will be able to better design the configuration of your SSL VPN. There are two modes you can use to access an SSL VPN. Both can build an SSL VPN connection, but they don't support the same features. Which should you choose? It depends on which applications you need to send through the VPN, the technical knowledge of your users, and whether or not you have administrative permissions on their computers. Tunnel mode supports the most protocols, but requires the installation of a VPN client, or more specifically, a virtual network adapter. To tunnel traffic using the virtual adapter, you must use FortiClient or its standalone FortiSSL VPN client component. Web mode requires only a web browser, but supports a limited number of protocols. Web access is the simplest SSL VPN mode. Like you would with any other HTTPS website, you simply log in to the SSL VPN portal web page on FortiGate. It acts like a server-side reverse proxy, or a simply secure HTTP/HTTPS gateway that connects you with the applications on the private network. The bookmark section on the SSL VPN portal page contains links to all or some of the resources available for the user to access. The Quick Connection widget allows users to type the URL or IP address of the server they want to reach. A web SSL VPN user makes use of these two widgets to access the internal network. The main advantage of web mode is that it does not usually require you to install extra software. Web mode has two main disadvantages. All interaction with the internal network must be done using the browser exclusively, through the web portal. External network applications running on the user's PC cannot send data across the VPN. This is a secure HTTP/HTTPS gateway mechanism that doesn't work for accessing everything, but just a few popular protocols such as HTTP, FTP, and Windows shares. How does web mode work? 1. Remote users establish a secure connection between the SSL security in the web browser and FortiGate's SSL VPN portal using HTTPS. 2. Once connected, users provide credentials in order to pass an authentication check. 3. Then, FortiGate displays the SSL VPN portal that contains services and network resources for users to access. Different users can have different portals with different resources and access permissions. Also notice the source IP seen by the remote resources is FortiGate's internal IP address and not the user's IP address. Tunnel mode is the second option FortiGate provides to access resources within an SSL VPN. Tunnel mode requires Fortinet's standalone SSL VPN client, FortiClient, to connect to FortiGate. FortiClient adds a virtual network adapter identified as FortiSSL to the user's PC. This virtual adapter dynamically receives an IP address from FortiGate each time FortiGate establishes a new VPN connection. Inside the tunnel, all traffic is SSL TLS encapsulated. The main advantage of tunnel mode over web mode is that after the VPN is established, any IP network application running on the client can send traffic through the tunnel. The main disadvantage is that tunnel mode requires the installation of a VPN software client, which requires administrative privileges. How does tunnel mode work? 1. Users connect to FortiGate through FortiClient. 2. Users provide credentials to successfully authenticate. 3. FortiGate establishes the tunnel and assigns an IP address to the client's virtual network adapter, FortiSSL. This is the client's source IP address for the duration of the connection. 4. Then, users can access services and network resources through the encrypted tunnel. FortiClient encrypts all traffic from the remote computer and sends it over the SSL VPN tunnel. FortiGate receives the encrypted traffic, de-encapsulates the IP packets, and forwards them to the private network as if the traffic originated from inside the network. Tunnel mode also supports split tunneling. When split tunneling is disabled, all IP traffic generated by the client's computer, including internet traffic, is routed across the SSL VPN tunnel to FortiGate. This sets up FortiGate as the default gateway for the host. You can use this method in order to apply security features to the traffic on those remote clients, or to monitor or restrict internet access. This adds more latency and increases bandwidth usage. When split tunneling is enabled, only traffic that is destined for the private network behind the remote FortiGate is routed through the tunnel. All other traffic is sent through the usual unencrypted route. Split tunneling helps to conserve bandwidth and alleviates bottlenecks. Good job! You now understand the SSL VPN operation modes supported by FortiGate. Next, you'll learn about how to configure SSL VPNs. After completing this section, you should be able to define authentication for SSL VPN users, configure SSL VPN portals, configure SSL VPN settings, define firewall policies for SSL VPNs. By demonstrating competence in configuring the SSL VPN settings on FortiGate, you will be able to better design the architecture of your SSL VPN tunnels. To configure SSL VPN, you must take these steps. 1. Configure user accounts in groups. 2. Configure the SSL VPN portal. 3. Configure SSL VPN settings. 4. Create a firewall policy to accept and decrypt packets. This policy is also used to provide access to internal networks. 5. Optionally, configure a firewall policy to allow traffic from the SSL VPN client to the Internet and apply security profiles. User traffic will go to the Internet through FortiGate, where you can monitor or restrict client access to the Internet. Some steps can be configured in a different order than what is shown on this slide. The first step is to create the accounts and user groups for the SSL VPN clients. All FortiGate authentication methods, with the exception of remote password authentication using the Fortinet Single Sign-On (FSSO) protocol, can be used for SSL VPN authentication. This includes local password authentication and remote password authentication using the LDAP, Radius, and TACACS Plus protocols. You can also configure two-factor authentication with FortiToken for better security. The second step is to configure the SSL VPN portal or portals. An SSL VPN portal contains tools and resource links for the users to access. In tunnel mode, when you enable split tunneling, you need to select a routing address setting, which usually specifies networks behind the FortiGate for the SSL VPN users to access. Also, for tunnel mode, you need to select an IP pool for users to acquire an IP address when connecting. There is a default pool available within the address objects if you do not create your own. If you enable web mode, you can customize the SSL VPN portal and pre-configure bookmarks to appear for all users who log into the SSL VPN portal. Also, you can individually configure and link each portal to a specific user or user group so they have access to only required resources. This slide shows an example of an SSL VPN web mode portal page after the user logs in. It allows you to download a standalone client from the Download FortiClient drop-down list. This standalone client is used to connect to SSL VPN in tunnel mode. Also notice the SSL VPN bookmarks provide links to network resources. The settings for web mode allow users to use the administrator-defined bookmarks in the Bookmarks section. Users cannot modify administrator-added bookmarks. Use the widget in the Your Bookmarks section to add personal bookmarks. Access network resources directly using the Quick Connection widget. Let's explore the protocols and server applications available on the SSL VPN portal web mode through the Bookmarks or Quick Connection widget. Depending on the web portal configuration, one or more of the following are available. 1. HTTP/HTTPS allows you to access private websites. 2. File Transfer Protocol (FTP) allows you to transfer files between the SSL VPN client and hosts or servers located in the private network. 3. SMB/CIFS implements the Server Message Block (SMC) protocol to support file sharing between the SSL VPN client and a remote host or server in the private network. Windows file sharing through SMB/CIFS is supported through shared directories. 4. Virtual Network Computing (VNC) allows you to remotely control another computer within the private network. 5. Remote Desktop Protocol (RDP), similar to VNC, allows you to remotely control a computer running Microsoft Terminal services. 6. Secure Shell (SSH) allows the exchange of data between two hosts using a secure channel. 7. Teletype Network Emulation (Telnet) enables a virtual, text-only terminal in the SSL VPN to log into a remote host. 8. Citrix makes use of SOCKS to enable Citrix clients to connect to the SSL VPN port forward module in order to provide a remote connection. 9. Port forward provides the middle ground between web mode and tunnel mode. When the SSL VPN receives data from a client application, the data is encrypted and sent to FortiGate, which then forwards the traffic to the application server. Port forwarding is the most suitable solution for situations where tunnel mode isn't practical and the other web mode's bookmarks are not flexible enough. Tunnel mode provides a Layer 3 connection that users can run any application on. However, it is not always a feasible option because it requires the installation of the virtual network adapter, FortiClient, and users don't always have the administrative level access required to accomplish that. Web mode doesn't provide enough flexibility for application support because it wires to a limited number of protocols. SSL VPN users can log into the SSL VPN portal and select a port forwarding bookmark that defines a specific server application address and port, as well as which port to listen to on the user's computer. So on the user's side, rather than create a tunnel with an IP that is separate from the local IP, tunnel mode, port forwarding requires the installation of a port forward module, which is a Java applet that listens on local ports on the user's computer. As soon as the user's applications point to the Java applet by connecting to the loopback address 127.0.0.1, the applet proxy receives the application data on the user's computer, encrypts it, and sends it to FortiGate. FortiGate then forwards the traffic to the application servers within the private network. Note that port forwarding supports only applications that use the static TCP port. It does not support dynamic ports or traffic over UDP. Only two types of bookmarks can be used for port forwarding: Citrix and Port Forward. After you configure the SSL VPN portal, The next step is to configure the SSL VPN settings. Let's start with a connection settings section. Here, you need to map a FortiGate interface to the SSL VPN portal. The default port for the SSL VPN portal is 443. This means users need to connect to the IP address of the FortiGate interface mapped to the SSL VPN portal using port 443 HTTPS. If you enable Redirect HTTP to SSL VPN, users who connect using HTTP TCP port 80 will be redirected to HTTPS. Port 443 is the standard default port for administration of the HTTPS protocol. This is convenient because users do not need to specify the port in their browsers. For example, https://www.example.com/ automatically uses port 443 in any browser. This is considered a valid setup on FortiGate because you usually don't access the SSL VPN login through every interface. Likewise, you generally don't enable administrative access on every interface of your FortiGate. So even though the ports may overlap, the interfaces that each one uses to access may not. However, if the SSL VPN login portal and HTTPS admin access both use the same port and are both enabled on the same interface, only the SSL VPN login portal will appear. To have access to both portals on the same interface, you need to change the port number for one of the services. If you change the admin access port, this will affect the port number for that service on all interfaces. Also, an inactive SSL VPN is disconnected after 300 seconds, 5 minutes of inactivity. You can change this timeout using the idle logout setting on the GUI. Finally, like other HTTPS websites, the SSL VPN portal presents a digital certificate when users connect. By default, the portal uses a self-signed certificate, which triggers the browser to show a certificate warning. To avoid the warning, you should use a digital certificate signed by a publicly known certificate authority, CA. Alternatively, you can load the FortiGate self-signed digital certificate into the browser as a trusted authority. Define the tunnel mode client settings and the authentication rules that map users to the appropriate portal. When users connect, the tunnel is assigned an IP address. You can choose to use the default range or create your own range. The IP range determines how many users can connect simultaneously. DNS server resolution is only effective when the DNS traffic is sent over the VPN tunnel. Generally, this will be the case only when split tunnel mode is disabled and all traffic is being sent from the user's computer across the tunnel. Also, you can allow FortiClient-equipped endpoints to self-register over a tunnel mode SSL VPN. After the user authenticates, FortiGate sends FortiClient the IP address and port to be used for registration. If the user accepts the invitation to register, registration proceeds and the FortiClient profile is downloaded to the client. Users without FortiClient endpoint security connecting to the SSL VPN through a browser are redirected to a captive portal to download and install the FortiClient software. Finally, you can allow different groups of users to access different portals. In the example shown on this slide, teachers have access only to the web portal. Accountants can use FortiClient to connect in tunnel mode. The fourth and last mandatory step involves creating firewall policies for logging on. SSL VPN traffic on FortiGate uses a virtual interface called ssl.vdom_name. Each virtual domain, VDOM, contains a different virtual interface based on its name. By default, if VDOMs are not enabled, then the device operates with a single VDOM called root. To activate and successfully log in to the SSL VPN, there must be a firewall policy from the SSL VPN interface to the interface to which you want to allow access for the SSL VPN users, including all of the users and groups that can log in as the source. Without a policy like this, no login portal is presented to users. If there are resources behind other interfaces that users need access to, then you need to create additional policies that allow traffic from ssl.root to exit those interfaces. Any traffic from SSL VPN users, whether in web portal or tunnel mode, exits from the ssl.vdom_name interface. This slide shows an example of firewall policies that are configured to allow access to resources behind other interfaces that users need access to when connected through SSL VPN. Optionally, if split tunneling is disabled, you need to create an additional firewall policy from SSL.root to the egress interface to allow clients access to the Internet. You can also apply security profiles to this firewall policy to restrict users' access to the Internet. Good job! You now understand how to configure the FortiGate for SSL VPN connections. Next, you'll learn how to create multiple SSL VPN login sites for different user groups and manage user-added bookmarks. After completing this section, you should be able to configure realms for the SSL VPN portal, configure personal bookmarks for the SSL VPN portal. By demonstrating competence in understanding these topics, you will be able to create multiple SSL VPN login sites for different user groups and manage user-specific bookmarks. By default, all SSL VPN users will see the same bookmarks configured by an administrator and the same theme. By default, the features for customizing SSL VPN realms and SSL VPN bookmarks are hidden on the FortiGate GUI. To add flexibility to your SSL VPN deployment, you may consider configuring SSL VPN realms. The realms are custom login pages. They are usually for user groups, such as your accounting team and your sales team, but can be for individual users as well. With realms, users and user groups can access different portals based on the URL they enter. With different portals, you can customize each login page separately, as well as limit concurrent user login separately. Example of realms on a FortiGate: https://192.168.1.1, https://192.168.1.1/accounting, https://192.168.1.1/technical support, https://192.168.1.1/sales. After realms are set up, you must apply them in the SSL VPN settings window. Configure the authentication rules in order to map users to the appropriate realm. These settings allow different groups of users to access the defined portals by different realms. In the example shown on this slide, teachers have access only to their own realms. If they need access to the root realm to see the global portal, you would need to add an additional authentication rule for them. When users log into their individual portal, there is an option that allows them to create their own bookmarks. An administrator must enable the User Bookmarks option on the SSL VPN portal page to allow this. Administrators can view and delete user-added bookmarks on the SSL VPN Personal Bookmarks page. This allows administrators to monitor and remove any unwanted bookmarks that do not meet with corporate policy. On the FortiGate CLI, you can create bookmarks for each user. These bookmarks will appear even if the User Bookmark option is disabled in the portal, because that option only affects the user's ability to create and modify their own bookmarks, not administrator-defined bookmarks. Depending on the type of bookmark you want to create, you may need to configure additional information that the application requires, such as URLs for websites and folders for FTP sites. Good job! You now understand how to configure SSL VPN realms and review user-added bookmarks. Next, you'll learn how to harden SSL VPN access. After completing this section, you should be able to configure client integrity checking, apply two-factor authentication using security certificates, restrict clients by IP and MAC address. By demonstrating competence in understanding how to strengthen security for SSL VPN accesses, you will be able to restrict users, ensuring that your internal network is secure, and limiting the possibility of attacks and viruses entering the network from an outside source. When a user connects to your network through an SSL VPN, a portal is established between your network and the user PC. The VPN session is secured natively in two ways. The connection is encrypted, and the user must log in with their credentials, such as a username and password. However, you can configure additional security checks to increase the security of the connection. One method of increasing your security is through client integrity checking. Client integrity ensures that the connecting computer is secure by checking whether specific security software, such as antivirus or firewall software, is installed and running. This feature only supports Microsoft Windows clients because it accesses the Windows Security Center to perform its checks. Alternatively, you can customize this feature to check the status of other applications using their globally unique identifier, GUID. The GUID is a unique ID in the Windows Configuration Registry that identifies each Windows application. Client integrity can also check the current software and signature versions of the antivirus and firewall applications. Client integrity checking is applicable to both web mode and tunnel mode. The client integrity check is performed while the VPN is still establishing, just after user authentication is finished. If the required software is not running on the client's PC, the VPN connection attempt is rejected, even with valid user credentials. Client integrity is enabled per web portal and can be configured using CLI commands. The list of recognized software, along with the associated registry key value, is available on the CLI. Software is split into three categories: antivirus, AV, firewall, FW, and custom. Custom is used for customized or proprietary software that an organization may require. Administrators can configure these settings only on the CLI. The disadvantage of enabling client integrity checking is that it can result in a lot of administrative overhead because of the following factors. All users must have their security software updated in order to successfully establish a connection. Software updates can result in a change to the registry key values, which can also prevent a user from successfully connecting. As such, administrators must have in-depth knowledge of the Windows operating system and subsequent registry behavior in order to properly make extended use of, as well as maintain this feature. You can also harden your SSL VPN connections by applying two-factor authentication through security certificates X.509 by either requiring clients to authenticate using their certificates. When the remote client initiates a connection, FortiGate prompts the client browser for its client-side certificate as part of the authentication process. Installing FortiGate CA certificates on your client's browsers. You can secure SSL VPN access by restricting host connection addresses. Setting up IP restriction rules can be very useful when considering proper security configuration. Not all IPs need access to the login page. This method allows you to set up rules to restrict access from specific IPs. One simple rule is to allow or disallow traffic based on geographic IP addresses. The default configuration is set to limit access to specific hosts, but the hosts field is empty. You must specify the IP address or network in the hosts field. This will allow only those users to access the login page. The Allow Access from Any Host setting allows all IPs to connect. On the CLI, you can configure the VPN SSL setting to disallow specific IPs. You can also configure FortiGate to check against the client's MAC address when remote users attempt to log in to the SSL VPN portal. This makes sure that only specific computers or devices are connecting to the SSL VPN tunnel. This setting offers better security because passwords might be compromised. MAC addresses can be tied to specific portals and can be either the entire MAC address or a subset of the address. Good job! You now understand how to strengthen security for SSL VPN access. Next, you'll learn how to monitor SSL VPN sessions, review logs, configure SSL VPN timers, and troubleshoot common issues. After completing this section, you should be able to monitor SSL VPN connected users, review SSL VPN logs, configure SSL VPN timers, troubleshoot common SSL VPN issues, identify hardware acceleration components for SSL VPN. By demonstrating competence in SSL VPN monitoring and troubleshooting, you will be able to avoid, identify, and solve common issues and misconfigurations. You can monitor which SSL VPN users are connected on the SSL VPN Monitor page. This shows the names of all SSL VPN users that are currently connected to FortiGate, their IP addresses, both inside the tunnel and outside, and connection times. When a user connects using tunnel mode, the Active Connections column shows the IP address assigned by FortiGate to the FortiSSL virtual adapter on the client's computer. Otherwise, the user is connected only to the web portal page. You can also review SSL VPN logs. Selecting VPN events shows when there is a new connection request and if the SSL VPN tunnel is established and closed. Selecting user events provides the authentication action related to SSL VPN users. Selecting endpoint events shows when users establish or close an SSL VPN in tunnel mode using FortiClient. When an SSL VPN is disconnected, either by the user or through the SSL VPN idle setting, all associated sessions in the FortiGate session table are deleted. This prevents the reuse of authenticated SSL VPN sessions, not yet expired, after the initial user terminates the tunnel. The SSL VPN user idle setting is not associated with the firewall authentication timeout setting. It is a separate idle option specifically for SSL VPN users. A remote user is considered idle when FortiGate does not see any packets or activity from the user within the configured timeout period. During a long network latency, FortiGate can time out the client before the client can finish the negotiation processes, such as DNS lookup and time to enter a token. Two new CLI commands under Config VPN SSL settings have been added to address this. The first command allows you to set up the login timeout, replacing the previous hard timeout value. The second command allows you to set up the maximum DTLS hello timeout for SSL VPN connections. Also, timers can help you to mitigate vulnerabilities, such as slow LoRaS and Are You Dead Yet, that allow remote attackers to cause a denial of service through partial HTTP requests. The following are some best practices to keep in mind when using SSL VPNs. These best practices can also be helpful in many SSL VPN troubleshooting situations. Enable cookies in your web browser. Set internet privacy options to high in your web browser. Use a FortiClient version that is compatible with your FortiOS firmware. Enable split tunneling or create an egress firewall policy for SSL VPN connections in order to allow access for external resources. Connect to the correct port number. Add SSL VPN groups, SSL VPN users, and destination addresses to the firewall policies. Flush inactive sessions by timeout. There are several useful troubleshooting commands available under Diagnose VPN SSL. They include list, lists logged on users, info, shows general SSL VPN information. Statistics shows statistics about memory usage on FortiGate. HW acceleration status displays the status of SSL hardware acceleration. The command shows the entire list of debug messages for SSL VPN connections. Remember, to use the commands listed above, you must first run the diagnose debug enable command. FortiGate devices that have CP8 or CP9 content processors, which accelerate many common resource-intensive, security-related processes, can offload SSL VPN traffic to a high-performance VPN bulk data engine. This specialized IPsec and SSL TLS protocol processor processes most of the latest well-known algorithms for encryption. By default, the offloading process is set up. If for testing purposes you want to disable it, you can do it using the CLI only at the firewall policy configuration level. You can also view the status of SSL VPN acceleration using the CLI. Congratulations, you have completed this lesson. Now you will review the objectives that you covered in the lesson. This lesson covered the following objectives: define a virtual private network, VPN, describe the differences between SSL VPN and IPsec VPN, describe the differences between SSL VPN modes, define authentication for SSL VPN users, configure SSL VPN portals, configure SSL VPN settings, define firewall policies for SSL VPN, configure realms for SSL VPN portal, configure personal bookmarks for SSL VPN portal, configure client integrity checking, apply two-factor authentication using security certificates, restrict clients by IP and MAC address, monitor SSL VPN connected users, review SSL VPN logs, configure SSL VPN timers, troubleshoot common SSL VPN issues.